In this video, I will be giving comments about the assignment about the value at risk and expected shortfall report based on the Apple stock. The goal of this report is to evaluate the impact of the different methodologies proposed, identify the model risk for the assumptions defined, and the different modeling choices. Eventually, we want to propose the most appropriate methodology for this portfolio. For the specifics of the analysis and calculations, we refer to the explanations within the report itself. The focus in this video will be on the conclusions we have made from our analysis. First of all, the model selection. After backtesting both the value risk and expected shortfall measures, we have decided that the best model is the EWMA. This report overall ranks the EWMA method first within the value risk models based on their predictive performance. It can capture the time-varying volatility and correlation of returns and can be more reliable than historical value at risk during periods of market stress or sudden changes in the risk profile. It does not assume equally weighted observations in volatility, unlike the parametric approach. As may be seen in the graph on the left, normal and historical value at risk follow a similar tendency when backtesting the value at risk. While EWMA better integrates the volatility of the returns, parametric and historical methods not only do they show a higher number of exceptions, but also a larger difference between the value of the losses and the value at risk. We see a similar trend in the graph on the right, which is the backtesting of the expected shortfall. Finally, this is confirmed with the tests that I'm showing on the slide right now. The green qualification under the traffic light test and the except for the different other tests such as the BIN, POF, CCI, and TBFI. Now, for the model risk, there are several assumptions of the exponentially weighted moving average method. Like the assumption of a normal distribution that may affect its accuracy and increase model risk. The main assumption under this value risk model is a selection of the smoothing parameter. One way to minimize this model risk is to experiment with different decay factors. Alpha is equal to 0.94 seems to fit our data. Another assumption this model does is to assume a constant degree of weighting, which is hardly the case in practice. To minimize the model risk, it is important to validate the assumptions of the EWME value at risk. Some of the following measures may help to reduce the model risk. First of all, stress testing. We can evaluate the performance of the model under extreme scenarios that may not be captured by the assumptions of the model. Secondly, scenario analysis. To evaluate the sensitivity of the model to changes in the assumptions, such as changes in the distribution of returns or the correlation between the returns, or backtesting as we did in the analysis itself. Finally, we can conclude that after conducting the analysis, the most appropriate method is the EWMA. To improve the accuracy and robustness of the analysis, we could combine the EWMA method with other methods such as Garch methods.